Hello everyone, welcome back to the video. Now in the previous video you have learned about electrochemical cells and you know that there are two types of electrochemical cells. One of it is known as the galvanic cell, and this video is going to focus only on the galvanic cell. So you have to know one thing, that is galvanic cell is actually a setup where you are converting chemical energy to electrical energy. Yeah, you are converting chemical energy to electrical energy. And the chemical energy we are talking about here comes from the redox reaction that will take place. If you could still remember, redox stands for reduction and oxidation. So in this particular electrochemical cell, spontaneous redox reactions happen, and therefore the chemical energy will then be converted to electrical energy. Now in this picture, it shows you the main components that you will actually find within an electrochemical cell. Number one, you will see an external metal wire connecting the two electrodes, which is immersed in the solution. And number two, the galvanic cell would also have a salt bridge. So this salt bridge connects the solution of both cells, both half cells. It connects it, you can see that. And inside the salt bridge, there are free ions. And when this electrochemical cell is operating, the free ions inside could actually move freely. Now that you know the special characteristics about the galvanic cell, there are again two types of galvanic cells that you will have to learn in this syllabus. The first one is called the metal half cell. Second one is called the solution half cell. Okay, so look at this picture, please. Could you be able to identify that it's actually a galvanic cell? If you actually look at these fillings, number one, you see a salt bridge, and number two, you see this external metal wire connecting the two electrodes. Therefore, we know it is a galvanic cell. Well, at the same time, we also know that it is actually a metal half cell under the galvanic cell because the two electrodes are actually made up of metal electrodes, and this metal electrode is actually immersed in a solution containing of its own ions. So if you can see here, the copper electrode here is immersed in a solution of copper ions, and the zinc electrode is actually immersed in a solution of zinc ions. So remember, redox reaction is supposed to take place. So the very first thing we have to learn here is to predict which half cell is the one that will undergo oxidation. In order to do that, you will have to refer to this metal reactivity series. You see the list of the metals here. So at the top of the list is potassium. So potassium is actually the most reactive metal of all. So in other words, potassium is the metal that will be oxidized easily. As the list moves down, the ease of the metal being oxidized actually gets lower and lower. And you should also know that oxidation is the opposite of reduction. Therefore, this is implying is also that potassium is also the metal that is the most difficult to reduce. So as we go down the list, copper would be reduced easily if you were to compare to potassium. Okay, back to our metal half cell here. So now that you know this between copper and zinc, would you be able to tell me which one will undergo oxidation? Hope you got the answer right. The answer is actually zinc, because zinc is on top of copper. Therefore, comparatively, zinc is the one that will be oxidized easily. So if I were to write a half equation, it will be zinc oxidized to become zinc ion plus electrons. So the zinc ion will actually remain within the solution. electrons wise, they will start to travel via the external wire and they move towards copper. Yeah, so if oxidation takes place here, obviously reduction is going to happen here. So if I were to write the reduction equation, it will be copper ions receiving electrons to become the copper metal, which will be deposited on the electrode itself. Now, sometimes writing the half equation itself is not enough because you are also required to write the overall equation of this entire metal half cell. So to write the overall equation, all you need to do is just to combine the two equations together. Okay, so we have zinc plus copper ions. The electrons are going to be cancelled out, yeah? Producing copper plus zinc ion. As simple as that. Another one thing is also that given this metal half cell, you should be able to tell me which electrode is the anode and which one is the cathode. This one needs a little bit of memorizing, okay? The electrode where electrons are leaving, this electrode will be known as the anode. In other words, anode is the place where oxidation will happen. And because electrons are leaving, it gives anode a negative charge. So if this is anode, obviously the copper electrode will be known as the cathode. Okay? And you know opposite things always attract each other. Therefore, in order for cathode to attract the electrons to move over, we will know that the cathode is always positively charged. We are still doing this metal half cell. So another one thing you also have to know about this is how to write a shorthand representation for this cell. Shorthand representation would be like, a summarized version of what is happening in this cell. Now, when you write a shorthand, we always start from the anode. So in the anode, you have zinc, which is oxidized to zinc ions. And then you draw a double line here. There comes the cathode. In the cathode, your copper ions are reduced to become the copper. Okay? So it's as simple as that. This is actually what we call it as the shorthand representation for this particular metal half cell. Remember, it's always the anode first, then the cathode. Within the anode, it will be the metal becoming the ion, and then at the cathode, it will be the ion becoming the metal. Right. So I've actually told you more or less everything about this half cell. Let's look at the picture again. I've explained to you already what the electrode does, what the solution does, and this metal wire, what does it do? It's used to transfer the electrons. The only one thing that I've not told you is actually about the salt bridge. Like, why is this salt bridge there? Like, why do we need it there? Okay, the reason is because look at this anode. Okay, electrons have left. So somehow some negatively charged particles have left this half cell. So in order to replace the negatively charged electrons moving out, what happens is within the free ions in the salt bridge, the negatively charged ions will be attracted towards the anode. Again, they move there is because they want to replace the negatively charged electrons that have left. So something have left what? So you are replacing with some other negatively charged ions. On the other hand, the cathode, because they have received negatively charged particles, so now the positively charged ions will be attracted towards them. It's like a way of balancing whatever they have before. Okay, a very common solution found in the salt bridge is always sodium chloride. Okay, a very, very popular one. to be found inside the salt, which is sodium chloride? Well, inside we have positively charged sodium and negatively charged chloride. Now you might be asked, why is it so popular? Why do we like to use sodium chloride so much? Okay, you have to know this. This is because whatever ions you use, right, you must ensure that these ions inside the salt bridge will not react with any of the ions in both of these half cells. Okay, and if you have sodium ion, you don't have to worry because sodium ions can never be reduced in the presence of water. Well, look at sodium. It's way up here. It's very reactive. Okay, so sodium ions cannot be reduced in the presence of water. Whereas for chloride ion, they can only be oxidized if they are found in a very, very high concentration. So because sodium chloride can never react with any of the ions here, so it makes it a very good choice for the salt bridge solution. Okay, I shall continue the solution half cell in the next video.